Hello, Prepare for Honors Math 2-3 students. Okay, this lesson's the first day of matrices. Matrices are used a lot in mathematics, especially higher level mathematics classes that you'll take when you get to college. So first, what is a matrix? A matrix is basically a rectangular array of numbers written within brackets. And as you can see here, down below, you'll see a couple of examples of what a matrix looks like. Now, the plural version, right, of a matrix is matrices. Okay. Now, within each matrix, there's a bunch of numbers that are arranged, right? The numbers in the matrix are called the elements of the matrix. And each matrix does have a dimension. So the dimensions of a matrix is the number of rows, right, by the number of columns. Now, just to let you know, the rows are horizontal, right? So row 1, row 2, the columns, right, are the vertical part. So column 1, column 2, and so on. So when we look down below here, determine the number of elements in a matrix and the dimension of the matrix. So right away here, number of elements. There are 1, 2, 3, 4 elements inside this matrix. And the dimension is, how many rows do I have? I have 2 rows by 2 columns. So this is a 2 by 2 matrix. Okay, the next one. Number of elements. If I look, there's 1, 2, 3, 4, 5, 6 elements, right? So we have 6 elements. In the dimensions, we have 2 rows by 3 columns. So this would be a 2 by 3 matrix. The next one, as you can see, there are 1, 2, 3, 4, 5, 6 elements. But if you look at the dimensions now, here there are 3 rows, but there are only 2 columns. So this would be, remember, it's rows by columns. So it would be 3 by 2 matrix. Letter D, there are 3 elements. And if I look, there's 1 row and there's 3 columns. So this is a 1 by 3 matrix. And the last one, there are obviously 2 elements, but there are 2 rows by 1 column. So that's a 2 by 1 matrix. All right, now, given a matrix, right, each element has a position, right? And the position of it is basically what row it is and what column it's in. So if I look at A here, that's in row 1 and it's also in column 1. So that's row 1, column 1. If I look at letter B, right, that's still row 1, but now it's in column 2. So that's row 1, column 2. Letter C, still row 1, but now it's column 3. So row 1, column 3. Letter D. Okay, now we've moved. This is row 2 now, right? This is column 1. So D is in row 2, column 1. E would be again row 2. But now it switched to column 2. And F would be row 2, column 3. That's going to come to be very important down the road. Adding matrices. Basically, when we add matrices, all we're doing is adding the corresponding elements. And as you can see, B plus F will give you that one. C plus G would go here. D plus H would go here. So you're just adding the corresponding elements and putting them in the corresponding parts they're already in. Now when we subtract a matrices, first thing I like to do is change the subtraction to addition and basically switch the signs on each element in the matrix that follows this subtraction sign. So this becomes basically A minus E, right? Or A plus negative E. Then B plus negative F is the same as B minus F. So basically what you're going to do is distribute the minus sign and just add the corresponding matrices. So here, one other thing. In order to add or subtract, right? In order to add or subtract, your matrices have to have the same dimensions. Okay, that's really, really, really important. So when I look here, this matrix is 3 by 1. So that's 3 by 1. This is 3 by 1. Therefore, we can add them. So now, all I'm going to do, 3 plus negative 1, that would give me 2. Then I'm going to basically add these together. Negative 3 plus 5 would give me 2. And then the last one, 5 plus 5, would give me 10. And there we go. Letter B. Since we're subtracting these, I'm basically switch that to addition. Then I'm going to switch these signs. Positives become negative, negatives become positive. Right? Because when I subtract the negative, it's the same as adding. So now all I'm going to do is add the corresponding elements. 4 plus negative 5 will give you negative 1. 0 plus 6 is 6. 5 plus 1 is 6. Negative 4, right? That's going to be negative 4 minus 6. It's going to give you negative 10. Negative 2 plus 6 is 4. And 3 plus 5 is 8. And we are done. So subtraction only has one additional step. Now, the next one, we're adding these. 2 by 2, 2 by 2. So 3 plus negative 1 is going to give you 2. 0 plus 4 will give you 4. Negative 5 plus 2 will give you negative 3. And negative 1 plus 0 would be negative 1. For this last one, we are subtracting. So again, switch it to addition and switch the signs on all of these elements. Okay? So again, no different. I'm basically going to do 7 plus 2 will give you 9. 4 minus 5 will give you negative 1. 0 minus 3 will give you negative 3. Negative 2 plus 10 would give you 8. Negative 1 plus 3 would give you 2. And 6 plus negative 1 would give you 5. And we are done here. All right, so adding and subtracting should be very, very easy. Now, when I look at E, right away, if I look, this is a 4 by 1 matrix. This is a 1 by 3 matrix, right? This is not possible to add or subtract because the dimensions are not the same. So next, scalar multiplication. This is relatively easy too. All you're going to do is multiply everything in the matrix by this outside number. So you would get A times B, A times C, A times D, A times E, and we are good. So when I look at example 4, right? The first spot is going to be negative 2 times negative 3, which is going to give you positive 6. Negative 2 times negative 2 is positive 4. Negative 2 times 6 is negative 12. Negative 2 times 3 is negative 6. And for this last one, 4 times 5, that's going to give you 20. 4 times 2 is 8. 4 times 6 is 24. 4 times negative 4 is negative 16. 4 times 3 is 12. 4 times 1 is 4. 4 times 5 is 20. 4 times negative 6 is negative 24. And we have our new matrix. Okay? So, scalar multiplication, really easy also. Now, multiplying matrices, this gets a little tricky, right? Now, when we multiply matrices, we're basically going to multiply rows by columns, right? So it says, to multiply matrices, number of columns in the first matrix must match up with the number of rows in the second matrix. So again, we have rows by columns, rows by columns. If you look here, the number of columns in the first matrix must match up with the number of rows in the second matrix. If that can't happen, you cannot multiply these matrices. Now, the resulting matrix will end up being equivalent to the number of rows in the first matrix by the number of columns in the second matrix. So here, 2 by 2 times a 2 by 2. So do these match up? Yes. Since those match up, I know my resulting matrix will be a 2 by 2 matrix. Now, when you multiply matrices, it's basically going to be row 1 times column 1 is going to give you your first element. We're going to talk about how to do this in a minute. Then it's going to be basically row 1 times column 2. Then row 2 times column 1. And then the last one would be row 2 times column 2. Now here's the thing. When we multiply these rows and columns, right, you're basically going to do, in this case, when I multiply these, when I do row 1 times column 1, I'm basically going to multiply A times E and then add B times G. The next one, if I look, I'm going to do row 1 times column 2, which now ends up being A times F plus B times H. Next, when I do row 2 times column 1, C times E plus D times G. Then finally, row 2 times column 2 would be C times F plus D times H. So I know this seems a little confusing, but I think once you see a couple of examples, you'll see it's not that bad. So example 6 says, the dimensions of two matrices is given. Determine if it's possible to find the product. If so, give the dimensions of the product. So remember, if I have a 4 by 3 times a 3 by 2, these have to match up, the columns and the rows, right? And if I look, my resulting matrix would be a 4 by 2 matrix. The next one, I have a 3 by 4 times a 3 by 2. If you look, Do these match up? No. Therefore, not possible to multiply, right? Because the columns in the first matrix do not match up with the column of the second, or rows of the second matrix. So now, when we go to multiply these, okay? So here I have a 2 by 2 and a 2 by 2. So I know my resulting matrix is going to be a 2 by 2. So when I break it down and go to multiply these, so the first thing we're going to do here to multiply is we're going to do row 1 times column 1. And the reason is this spot is row 1, column 1. So row 1 times column 1. And when we do this, we take the first term times the first term plus the second term times the second term, right? So negative 2 times negative 4 plus negative 2 times negative 3. Now next, we're going to do row 1, column 2. So row 1 times column 2. So again, it's the first term, so negative 2 times first term is 4 plus negative 2 times 4 again. Next, we know it's row 2, but now column 1. So row 2 times column 1. So that would be 4 times negative 4 plus 1 times negative 3. Then the last one would be row 2, row 2, row 2, column 2. So row 2 times column 2, so 4 times 4 plus 1 times 4. And that would give us, if I look, that's going to be 8 plus 6, which is 14. This is negative 8 plus negative 8, which is negative 16. Then negative 16 plus negative 3 is negative 19. Then 16 plus 4 would be 20. And that is what we get when we multiply these matrices. So if I look at the next example, here I have a 2 by 3 matrix, and here I have a 3 by 2 matrix, right? So basically, I look, these match up, so we're good. And if I know it's hard to believe, but we're going to end up with a 2 by 2 matrix. So what we're going to do here, the first one is row 1 times column 1. Row 1 times column 1. So this would give me negative 2 times negative 1 plus negative 1 times negative 3 plus negative 3 times negative 1. So when you really break it down, guys, it's the first times the first, the second times the second, the third times the third in a way. Okay? So that's kind of what you're doing with each of these. So the next one would be row 1, column 2. So now we're going to do row 1 times column 2. And again, we're going to do the first ones and multiply them. So negative 2 times 0 plus negative 1 times 6 plus negative 3 times negative 3. Now we're going to move on to row 2 times column 1. Row 2, column 1. So, first ones we multiply, plus second ones we multiply, plus third ones we multiply. And finally, we're going to move on to row 2, column 2, which is row 2, column 2. So 3 times 0 plus 4 times 6 plus 6 times negative 3. And all we do now is evaluate this. So, this would give me 2 plus 3 plus 3, which would give me 8. 0 minus 6 plus 9, that would give you 3. Negative 3 minus 12 minus 6 would give you, what is that, negative 21? And then 0 plus 24 minus 18 would give you 6. And we are done. Okay, so now here, next one, we have 2 by 2 multiplied by a 2 by 3. These match up, and we know we're going to end up with a 2 by 3 matrix. So we go to multiply these, right? So the first one is row 1 times column 1. So row 1 times column 1 would give me 4 times negative 1 plus negative 4 times 5. Then we're going to go row 1, column 2. So that would be 4 times negative 2 plus negative 4 times 6. Now we're going to move on to row 1, column 3. So now 4 times negative 1 plus negative 4 times 1. Now here, we're going to go to row 2, column 1. So that's 1 times negative 1 plus negative 6 times 5. Then it's row 2, column 2. So 1 times negative 2 plus negative 6 times 6. Now it's row 2, column 3, and that would give you 1 times negative 1 plus negative 6 times 1. And now we can evaluate these. Negative 4 minus 20 is negative 24. Negative 8 minus 24 is negative 32. Negative 4 minus 4 would give you negative 8. 4 minus 30 would be negative 26. Negative 3 minus 36 would be negative 39. And then negative 1 minus 6 would be negative 7. And we are done. Now last, if I look here, this is 2 by 2. This is a 3 by 2. These don't match up, so you would not be able to multiply these. Okay, that would not be possible. So, go ahead, try the homework, and let me know if you have any questions.